So if you hold out your hand right now and just wave it back and forth, you probably think you are just moving it through empty space.
Right. Yeah.
I mean, you look around a room or you look up at the night sky, and the default assumption is that there's a whole lot of nothing out there. Just a giant, dark void acting as a massive container with a few stars, planets, and, well, people scattered around inside it.
Exactly. And that is the classical intuitive view we all grew up with, you know. We see objects as independent things existing inside of space, as if space itself is just an inert, empty box holding everything else.
But today we are diving into a theoretical framework that takes that entire concept, shatters it, and basically tells you that the empty box does not actually exist.
It's wild.
Yeah, the space you just waved your hand through isn't empty at all.
Oh.
According to a really groundbreaking stack of physics notes we are unpacking today, that empty space is actually the most tightly wound maximum tension structure in the universe.
It is a profound paradigm shift. We're looking at a model called the Mechanical Relativity Project.
Yep.
And if you are wondering why you should care about theoretical physics today, think of it this way. In a world of constant information overload and shifting realities, understanding the fundamental rules of the universe gives us an incredibly grounding perspective.
Totally.
Because standard physics often relies on something called the Planck scale, which involves distances and energies so extreme they are completely unobservable. They exist in purely mathematical realms.
Right, like we can't ever actually see them.
Exactly. This new model, however, zooms in on the observable nuclear scale. It attempts to explain how mass, time, and space itself emerge from something we can physically measure and understand.
Okay, let's unpack this, starting with the rules of the game. Because, any robust theory needs a solid foundation before it gets into the heavy math.
Definitely.
The source material begins with Phase 1, which lays out 7 foundational postulates. These are basically the core mechanics of an mechanical universe. The first one is the principle of mechanical connectivity. It argues that the universe is a dynamic, tensed, connective structure. So, if I'm reading this right, mass, energy, and momentum aren't independent objects at all. They're just localized areas of tension within a universal web.
That is the core premise, yeah. Imagine a completely uniform field of tension. Everything we perceive as a solid, physical object, a planet, a chair, an atom, it's just a variation, a specific tightening, or a knot within that foundational field.
Okay, I can picture that.
Nothing exists outside of this structural connectivity, which logically leads to the second postulate, the principle of finite maximum tension.
Now, this one immediately made me pause. It states there's an absolute maximum limit to tension in nature. Like, the universe has a snapping point that it simply cannot exceed.
Right.
But standard physics tells us that inside a black hole, gravity and density collapse into an infinite point, a singularity. Are these notes saying that those infinities don't actually exist?
Precisely. In standard models, when equations spit out infinity, physicists usually view it as a breakdown of the theory. The math just stops working.
Like an error message.
Exactly. The mechanical model introduces this maximum tension limit as an ultimate cosmic safeguard. By mathematically capping how much tension can exist in one place, it prevents those infinite collapses.
Wow.
The structure can only pull so hard before it hits a physical boundary condition, and that maintains the stability of the entire universe.
That makes a lot of sense. It completely removes the error message of infinity.
It really does.
So the third rule is the principle of relational quantization. In standard quantum mechanics, quantization, the idea that energy comes in distinct, chunky packets instead of a smooth flow, always felt to me like a rule that was just arbitrarily imposed.
Yeah, a lot of people feel that way.
Like the universe is chunky because the math says it has to be. But this framework argues that quantization arises organically from the tension itself.
Right, it frames quantization not as a mysterious external law, but as a mechanical necessity. The structure is constantly seeking balance. The chunkiness you mentioned is simply the natural way this tense network balances its internal forces. It's relational.
I see. Then we hit the fourth postulate, which is arguably the biggest philosophical leap in the entire first phase, the principle of emergent geometry.
This one is huge.
Let me try an analogy here to see if I'm grasping the mechanism. Instead of the cliché trampoline or spiderweb comparisons, let's think of it like a digital photograph.
Okay, I like that.
Space-time isn't the blank canvas that a picture is painted onto. Space-time is the picture itself, which only emerges when millions of individual pixels of tension are packed together. The distances and curves don't even exist until the tension creates them.
What's fascinating here is how elegantly Your digital photograph analogy aligns with the math. The notes are very explicit. Space-time is not a fundamental a priori entity.
Right.
The geometry of the universe, what we perceive as the bending of space or the flow of time, emerges purely from how this mechanical tension is distributed. The tension doesn't exist in space-time. Space-time exists because of the tension.
That completely reorganizes how you think about movement, which transitions perfectly into the fifth and sixth rules. The principle of unified relational action says that any physical action is just the transfer of this tension across the structure.
Like a ripple moving through those pixels.
Exactly. And then the principle of velocity limitation fundamentally reframes the speed of light. The speed of light, c, isn't actually about light or photons at all, is it?
Not at its core, no.
No.
Standard physics often treats the speed of light simply as the velocity of a particle moving through a vacuum.
Right, like a photon shooting through space.
Right. But in this model, c is the absolute ultimate limit of how fast tension can transfer through the connective structure. It's the maximum speed of causality.
Oh, wow.
A ripple can only travel through a medium as fast as the physical properties of that medium will allow. The structural tension itself dictates the speed limit of the universe.
That is so cool. And wrapping up phase on is the seventh rule, the principle of hierarchical scales. It states that whether you are looking at an atomic system, a nuclear bond, or a massive cosmic system like a galaxy, they aren't playing by different rules.
Yeah.
They all obey the exact same relational structure, just operating at different scales of tension.
And by defining the universe through a unified lens of tension, maximum limits, and emergent geometry, the author has created a remarkably unified foundation. We aren't forced to juggle a dozen different forces or invent new physics for different sizes of objects. We are looking at one unified connective structure.
Okay, so that's the underlying philosophy. That's the structural blueprint. But, theoretical physics requires numbers. It requires testable, measurable values.
Always.
That takes us into phase two. If the universe is a web of tension, how do we measure something that invisible? What's the fundamental unit of this web?
This is where we introduce the driving engine of the entire theory, Mullum's constant.
Right. And the value the notes assign to Mullum's constant, represented as G sub m, is massive. It's approximately 1.5142 times 10 to the 29th power.
A huge number.
A number with 29 zeros.
Wait, Newton's gravitational constant is famously a tiny, incredibly weak number?
Yeah.
How can a fundamental universal constant be that astronomically massive?
It doesn't.
Doesn't that completely break our understanding of gravity?
Well, it would if it were describing the same kind of gravity.
Oh, okay.
But that is the crucial distinction the source material makes. Newton's gravitational constant describes weak, macroscopic gravity, the force pulling an apple to the ground or holding a distant moon in orbit.
Right, everyday gravity.
Exactly. Mullum's constant shares the exact same dimensional units, but its physical meaning is entirely different. It is a structural tension coupling constant. It describes the deep, fundamental structural bonding at the nuclear and quantum level. That bond isn't weak. It is almost unfathomably strong.
The author actually calls the central equation of this theory the most dangerous and important equation of the whole model.
Yeah, that's a bold claim. Very. It balances Mullum's constant and a reference mass on one side against the quantum structure and the speed of light on the other.
So let's break down the mechanics of why that equation is so powerful. On the right side, you have the established constants of our universe, the quantum limits of action, and the maximum speed of causality.
Okay.
On the left side, you have this new structural tension, Mullum's constant, paired with a very specific reference mass. This single equation essentially builds a bridge. It unites the quantum world, the limits of relativity, and the fundamental tension of the universe into one cohesive statement.
And when you actually crunch the numbers using that bridge, phase two spits out specific physical values. For
Right.
instance, it calculates a reference mass, an osomechanical length, and an osomechanical time. But these aren't just arbitrary outputs. The notes emphasize that this reference mass perfectly represents the medium binding the electron to the proton and the proton to the neutron.
Yes.
It is literally calculating the exact structural glue of an atom.
It defines the intermediate state of matter. And this leads to the most significant paradigm shift in the model's physical application.
Here's where it gets really interesting. Phase two takes those foundational units and derives a reference energy and a reference density.
Yeah.
The energy comes out to approximately 256 mega electron volts. The density comes out to about 10 to the 18th power kilograms per cubic meter. I had to read that section twice because those are not just random math outputs.
No, they aren't.
Those numbers perfectly match the actual nuclear binding energies and baryonic densities that experimental physicists observe in the real world. Why does it matter that a theoretical equation accidentally matches a real-world nuclear density?
Well, if we connect this to the bigger picture, it matters because standard physics models often have to work backward. They observe the nuclear density in a lab and then try to construct mathematical models that accommodate it. But the mechanical model predicts it organically from first principles.
It doesn't have to guess.
Exactly. It's not retrofitting the math. The sources provide a direct side-by-side comparison between traditional Planck units and these new orthomechanical units.
Right.
Planck units are derived purely from macroscopic gravity. Because gravity is such a weak force, Planck units exist at a scale that is unbelievably tiny, like billions of times smaller than a proton.
So, totally unobservable.
Right. Its theoretical territory so extreme we can never physically build a machine to probe it. But mechanical units, built on Mullum's constant, sit exactly at the nuclear scale. The model builds its foundation around the strongest, most fundamental quantum bonds that we can actually observe and measure right now.
It takes theoretical physics out of the unreachable void and places it right in the heart of the atoms making up the microphone in front of me.
Yeah, it grounds it in reality.
But as anyone who has studied physics knows, a theory can have beautiful philosophy and intriguing numbers, but it instantly dies if its dimensions don't balance.
Oh, absolutely.
If the raw units of length, mass, and time don't equal out on both sides of the equal sign, the theory is scientifically dead on arrival.
Which brings us to the ultimate crucible, phase 3. The dimensional proof. The source material views this as the most critical stage of validation. The goal is to prove that the mechanical model possesses a completely closed, internally consistent dimensional structure.
So instead of reciting the raw algebraic formulas, let's think of dimensional analysis like balancing an incredibly complex, high-stakes accounting ledger.
Okay, good visual.
On the left side of the ledger, you have the raw materials of the universe, the structural tension of Mullum's constant, and the mass of the fundamental bonds. On the right side of the ledger, you have the cosmic speed limit and the rules of quantum mechanics. When the author crunched the foundational units of length, mass, and time for both sides, they had to match perfectly.
And they do. When you break the entire central equation down to its rawest dimensional components, both sides of the ledger yield the exact same combination of volume, mass, and acceleration. The mathematical foundation is utterly flawless. The sources then rigorously subject mechanical length, time, energy, maximum tension, and action to the same test.
Right.
Every single concept perfectly derives into its proper, real-world physical unit. Nothing is left hanging. There are no leftover variables or illogical fractions.
But the true mic drop moment of phase 3 happens in section 310. The dimensionless structure.
Oh, yeah. This is great.
The notes introduce something called the mechanical fine structure constant. It is a complex equation involving Mullum's constant, the mass of an electron, the mass of a proton, quantum mechanics, and the speed of light.
A lot of heavy hitters.
Right. And when they run the dimensional ledger on this massive equation, the top half and the bottom half mirror each other exactly.
Yeah.
They cancel each other out completely, and the entire equation collapses down to equal exactly 1.
It generates a true, pure, dimensionless constant, a mathematical ratio that requires no physical units at all to express its truth.
I mean, it is deeply satisfying when chaotic math neatly collapses down to a single digit. But I have to ask, so what does this all mean? Why is a naturally emerging dimensionless constant such a monumental deal for a physicist?
Well, this raises an important question about how we have historically constructed our models of reality. Often, when physicists are building a framework, they run into gaps.
Right.
To make their equations match what we see in telescopes or particle accelerators, they have to insert fudge factors. They manually drop in constants, numbers that just happen to make the math work, even if we have absolutely no mechanical understanding of why that number is what it is.
Like using a mathematical band-aid to cover up a hole in the theory?
Precisely. It's an implicit admission that our understanding of the underlying machinery is incomplete. But the mechanical theory doesn't require any band-aids. The structure of the theory itself generates a completely closed, naturally dimensionless system.
That's incredible.
By proving that the structural tension perfectly balances the quantum and relativistic limits to equal 1, it strongly implies that the theory hasn't just invented a clever mathematical trick. It suggests that this model has uncovered a genuine foundational truth about how the physical universe organically balances itself.
It is like discovering the source code of reality, running a diagnostic test, and finding out it compiles perfectly with zero errors on the very first try.
Exactly.
We have gone on an incredible journey today. We started with phase one, basically tearing down the idea of independent objects in an empty box and replacing it with 7 postulates defining a dynamic, interconnected web of tension where space-time itself is just an emergent picture.
We then explored phase 2, where the introduction of Mullum's massive constant shifted the bedrock of physics away from the unobservable Planck scales, anchoring it firmly in the tangible, measurable nuclear bonds that hold our world together.
And finally, phase 3, where we walk through the rigorous dimensional ledger that proves the theory is structurally bulletproof and naturally balanced.
It is a remarkable synthesis of complex mechanics. But I want to leave you with one final lingering thought to chew on today. Something that builds directly on the physical density values and the emergent geometry we unpacked.
Go for it.
If space-time isn't an empty container, if it is actually the emergent result of intense nuclear-scale structural tension, then every time you move your hand through what looks like thin air, you aren't navigating through emptiness at all. You're pushing through a perfectly balanced, mathematically flawless matrix of maximum unimaginable tension. What does it fundamentally change about your daily existence to realize that nothingness is actually the most tightly wound structure in the universe?
Man, that completely reorganizes how you experience the space around you. The dark void isn't a void at all. It's the ultimate connective tissue holding reality together. Thank you so much for joining us on this deep dive into the mechanical relativity project. Keep questioning the physical reality around you, keep looking closely at the nothingness, and we will catch you next time.